Actually, in this paper, somebody just asked me to do this paper first. So let's start with, there was a question in this paper. You can remember this is summer 17. For one, we're going to do the rest of the questions later. Questions are. Just a second. Just 1 second, let me find the question. This was question number 5. That's 3. Sorry, this is 4-2. So we're going to do question number 5 first. So it's this one. This was kind of a difficult question, so let's try and do this one. Now in this question, what's happening is that there's compound JKNL, and so remember, it's a difficult question. Here, when this question appeared, a lot of people were not able to actually do or attempt this question. So he says that compound JKNL and M are isomers of each other with the molecular formula C9H11NO, and all 4 isomers contain a benzene ring. So that means they've got a benzene ring, all of them. So JK and L, right? So all 4 of them. I mean, that's the basic structure. They both have. All of them have a benzene ring, and I'm going to draw those benzene rings. TKL also has a benzene, and this one also has a benzene. So that basically, out of 6 carbons, you're left with 3 carbons now. Then what else? What other information is given? A lot of information is given about JK and L. So 2 of the isomers contain a chiral center. You can remember this one has a lot of information given. The results of 6 tests carried out on JK, L, and M are shown in the table. So first one, he added cold HCl. So all 3, the first 3. What does that indicate? HCl. HCl is an acid, right? What does that mean? That means that JK and L, cold HCl, remember, they are bases, right? So they're all bases. So you got 3 options. Now, which compounds are basic? Which compounds are your bases in organic chemistry? Amines are basic. So JK and L are amines. This one is not an amine. Or we can say it's not basic. So that is the first information, that the first 3 react with HCl, the last one, M, does not react with HCl. Then 2,4-DNPH, that's an easy one. What does 2,4-DNPH tell you? Kiska test hota tha 2,4-DNPH? What does it tell you?
Carbonyls, carbon double bond O.
That tells you that you got a carbon double bond O, right? So all of them, I mean, the first 3. So carbonyl. So this one has serial bond O. This one also has. So it's either an aldehyde or a ketone. This one is also a serial bond O. So no serial bond over here. Like no carbonyl, basically. I mean, you're going to write carbonyl over here. Serial bond O is wrong. I said, then you have alkaline aqueous iodine. So this one and the third one have. So what does alkaline aqueous iodine tell you? That's an iodoform test. It's part of your AS. So it's probably this one. This is iodoform test. So it's either methyl with a carbonyl or a methyl with a CHOH. So either one of the two. So those are your two options. So methyl with cetyl bond O or methyl with CHOH. And this one as well. Or methyl with CHOH. Now, so that's this one. I said, then you have, can you hold on 1 second? This is going to be 2 minutes. You can try and figure out what the other ones are. Sorry. As a starting, where were we? As a Felling solution. So what does a Felling solution do? It's what does it prove?
Aldehydes.
That proves it's an aldehyde. So K is an aldehyde, right? So that means the carbonyl over here, that's an aldehyde. Well, that also kind of confirms the other ones are actually ketones. This one is also going to be a ketone, and this one is neither an aldehyde or a ketone, right? I said then we are at, now he's heating with NaOH. So when he's heating with NaOH, the molecule splits into two. Over here in the last one, it splits into two. So what is this? For this, I need the which molecule splits into two when you heat it with NaOH? Anyone, any idea?
Amide.
Okay, so you have so you've got where's the, just let me, so it is amides, right? Amides or esters. So it could either be an amide or an ester because both of them actually split into two, but I don't think we have any information. I'll just share the notes with you just a second. Where's the division chart? Not this one, just a second, this one. I said, you see amides over here. So either esters, dilute acid or dilute alkyl reflux, it will break down to form a carboxylic acid or an alcohol or an amide as well. If you have an amide, so it will break down and it will form. Merish, एक second. K will be एक second. Where's the paper? So I've actually lost the paper. So this one. K will be an aldehyde. अच्छा हाँ सही है, K will be, yeah, K will be an aldehyde. ठीक है, that's wrong. One second, let me rub that off. ठीक है, that's your. And this one is your ketone. And this is going to be an amide, most likely. Amide, or it could be an ester. Or an ester. So molecule splitting into two. It's definitely not an ester because the other one does not have an. The ester breaks down into an alcohol and a carboxylic acid. So you don't have any OH on the other side. So definitely not an ester. It's an amide. Is that clear? Achha, last one. This is azodide formation. Now azodides are formed by what thing? Azodides are formed by, if you look at the chart, azodides are formed by phenylamines. Like you have a phenylamine. This is formation of azodides. Diazonium salts are produced, and then you warm it with NaOH under alkaline conditions. And sorry, this one. Under NaOH, it will form an azodide. That's a colored dye. So this reaction, we're talking about this reaction over here. Phenylamines undergo this. So this means the molecule that he's talking about, that must be a phenylamine. So we're gonna say that this one, K, is a phenylamine. So just let me confirm. Yellow precipitate. Okay, there's another. Haris, yes, it's an ester will break down to form an alcohol and a carboxylic acid, or a salt of the carboxylic acid. So that is present, but the alcohol is not present. So that means it must be an amide. Is this part clear? So so we need to just make all 4 compounds now. So we've got, what was the formula? The formula again, it's C9H11NO, right? So you got C9 H11 and NO. Now remember, there's only one N. So in the first one, that one N is amine. So we've got a benzene. So I'm going to start with K. I think I can figure out K probably quicker. K is phenylamine. K has an aldehyde group as well. So how many carbons I've left? I've got 3 carbon atoms left. So what I'm going to do is I'm probably going to attach those 3 carbon atoms, and I'm going to make it into an aldehyde. And these are my H atoms. So I've got all these H atoms. So is my formula correct? It's H11. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I got, I think that's fine. Next one, it's a ketone. And it's going to give an iodoform test, and it's an amine as well. So what would this molecule look like? It's not a phenylamine. So you got a benzene. But remember, not a phenylamine. So I've got 3 carbon atoms. So I need to turn it into methyl with a ketone. And there's 1 carbon atom left, so that's CH2, and then I'm going to make it into a normal amine, an alkyl amine. So do I have the right number of H atoms now? 1, 2, 3, and there's going to be 1 H over here. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think that's fine as well. There's 1 O. Is that clear that this is fine? They're probably not going to count. They're not probably going to worry about the where on the benzene are the groups attached. That's probably not going to be an issue. This one, again, it's an amine, and it's got a ketone group. But the question is, how are J and L different? Like, how are they different? Did they give any information about how J and L are different? Soluble, orange press plate, pale press plate, no reaction, no dye produced. So J and L are exactly the same. So he did mention something. He said two of the isomers contain a chiral center. So JKLM isomers are featured with the molecular formula C5 results of this sex test. So J and L are kind of exactly, I mean, they are exactly the same. Did he give us any information about J and L? So two of them contain a chiral center. Can I make this chiral? I'm probably going to come back to this at the end. I mean, let's do this one first. It's not an amine, it's an amide. So we're going to make it an amide. So there's going to be an NH, and they're going to be two or two carbons. That's 3 carbons. So that's 1, 2, 3, 4, and 5. So I've got this one, and finally I've got. So that's it. We have our 3 products. The problem is with J and L. The J and L, they have exactly the same test. So I can make an isomer of this. I can do that. That is one thing I can do. And let's just double check this one. Is this all the H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So that's also true. So this one, I can probably make an isomer of this. The only missing thing now is that he stated that 2 of them are chiral. So 2 of them are chiral. So I think J and L are basically, again, I'm just going to read through this. Can anyone spot a difference between J and L? J and L, exactly everything is exactly the same. He did not mention anything about them being different. So they might be structural isomers of each other. So you can kind of draw a ketone and it can also be an amine. So what I can do is I can draw another one. And that other one could be a ketone. And then it could have a carbon chain, and the NH2 could be attached over here. It could be an amine as well. So that is a possibility, and there would be. So you got your 11 H's. So now I'm going to check what the marking scheme is saying in this case. Okay, we did not come to the chiral part. We did figure out what the molecules were. The only missing thing is I have to make some of them chiral, 2 of them chiral, which can be done. Are there any chiral molecules over here at the moment? Is any one of them chiral or not? He said that 2 of them are going to be chiral. I mean, at the moment, I don't think there's anyone that's chiral. So what I can do is I can put the amine over here, right? If I put the NH2 over here, this can be made chiral. And I can't really make probably this one chiral. That's not possible. But I can make this one chiral. Like if I shorten the carbon chain and I can put a CH3 somewhere. I said there's one. I've made a few mistakes as well. The mistake is this one, methyl ketone. This must be a methyl ketone. So there must be a serial bond O in the middle. Okay, just a second. This must be, the double bond O must be over here. The iodoform test was positive for this one. Okay, this was a methyl ketone, this one. No, actually, no, not this one. This one was fine. I'm getting confused now. This one was fine. This was an aldehyde. This is this one. These two were the ones that had an iodoform test, which was positive. So that's definitely not the one, because the iodoform test is not going to come out to be positive. इसकी बात कर रहे हो, this one? I said no carbonyl. 2,4-DNPase test was not positive. So this is not a carbonyl, this is an amide. Is that clear? So छोटा कर लेते हैं. So we left with this part. We've done everything. There's a lot of information. Not an amide, so that's not an amide, it's an amide. That is done. Okay, so there's nothing wrong with this. This was an amine, so it is an amine. It was a phenylamine, so it's a phenylamine. It had a serial bond O, and it was an aldehyde, so the aldehyde is right at the end. So this one is also. तो कौन से double check कर लेते हैं? ठीक है, this is fine. This is fine. The problem is this one. This can't be it. I mean, this is wrong actually, because it had to be a methyl with a serial bond O. That's where the trouble is. So you got a methyl with a. So you need a methyl with a serial bond O. Now we have an issue. I said GNL. This is wrong. This one is wrong. I have to redraw this. Okay, so we're stuck at L. L is exactly the same as J. Everything is exactly the same as J. And they did state that. So what could be the other compound? The other compound could be that you could have a benzene and you could have CH, and that could have an NH2 branch. And then you could have a serial bond O and NH and CH3. Okay, now it makes sense. So you've got a methyl with a carbonyl, and you got an amine as well, a normal amine. It's making sense. Here, that's it. This one is chiral. One of them is chiral.
Why is J wrong? The one that
Which one?
J. So you said that J is wrong.
Why is
J wrong? J.
Yeah, I didn't get what. Why is J wrong? What's the question?
The first one that you did, you said it's wrong, that you drew it incorrectly.
The one that I cut over here, this one.
No, the other one over there. Yeah, yes,
yeah, but that's correct, right? But everything is fine over here.
Okay.
Because it said that you got an amine, a normal amine, not a phenylamine. So you got a normal amine. I just need one thing. I need one more chiral carbon atom, because he said that two of them are going to be chiral. So what I can do is I can change this a little bit, and I can make it. I got one chiral over here. I need another molecule that's chiral. So what I can do is I can probably change this one over here a little bit. I can get rid of one of the CH in the middle, and I can have just one C. And I can have C with CHs over here. Then this will be chiral. So I got my two chirals as well. So those are my 4 molecules. I think now everything works out. The only issue was J and L were exactly the same. They had exactly the same properties. So there must be structural isomers. So I did draw structural isomers for both of them. He didn't say, he said J and L are different molecules. He said out of the 4, 2 of them, they exhibit optical isomerism. I mean, that is how I'm interpreting it. So J and L were kind of different molecules. I mean, they were different isomers, and 2 of the isomers contain a chiral center. So that meant that there must be 2 completely different molecules that have a chiral center. But let's have a look. Did we get all of them right? Question number 5. Question number 5. Is this one. The position does not matter. So we got the amide right, that's fine. CH3 seal bond O, NH2, we got that right. I mean, that was the chiral, right? We drew that. We drew the branch one as well. That's also right. So all of them right. The first one had a lot of options. So I think we drew this one.
Sir,
Yeah.
why are there lines from the center, like from the circle?
That means they don't care about the position.
Oh, okay.
Like it could be anywhere, okay? So name the type of reaction occurring in test 5 that converts M into P plus Q. M into P plus Q. So that's hydrolysis. That's this is an amide that's breaking up. So that is hydrolysis. That happens. So it's hydrolysis. He just wanted the name of the reaction where the amide breaks off. Then he says suggest the structures for compound P and Q. So we've got this. So it's going to break. And this thing will form amine, and this one will form a carboxylic acid. So we're going to draw those structures. So one side will form the amine, the other side will form the carboxylic acid. And we have to be careful with this. This side forms the carboxylic acid. And the other side was the one that's forming. It had 2 carbon atoms. I mean, this one. So it had 2 carbon atoms on this side and this thing over here. So this is your amine. I said, then you have, so we draw them, so that's 5 marks. So it's a big question. It's like, 5 marks for the information over here, 5 marks for drawing the structure. So that's 10 marks. So that's why it's taking a lot of time. So it's in total, it's a 14-mark question with the tiny bits as well. K and L. हमने क्या समझा है K, J and L, K and L, right? So what is the marking scheme saying? I mean, these are the chiral centers in K and L. I said P and Q. Mesh वो वाला तो clear है ना? We right actually. I said P and Q are the opposite. Just make it opposite. And plus, it's alkaline hydrolysis, so it's going to be a salt of the carboxylic acid. This is this one, and this one is this one. So I think we're done with the question. It's the last thing is compound N is another isomer which has the same molecular formula as C9 and also contains a benzene ring. It contains the same functional group as M. I'm too tired to do this one. So there's another isomer of the same thing, contains a benzene, same functional group as M. So where's M? So what is the functional group in M? It's an amide, right? So it's an amide, right? With the same molecular formula. So it's got an amide. When heated with NaOH, it produces ethylamine. So I think the amide is slightly and a sodium salt W. So in this case, the amide is probably slightly to the रनिए 710 पे, ठीक है? अच्छा ethylamine किधर है? Now we've got a problem, and that is he's saying that. What is he saying in the last part? It's a 1-mark question. It contains same functional group as M. So when heated with NaOH, it produces ethylamine. So the problem is that this produces ethylamine. So it's, how can you have an isomer of this with the same functional group? This is ethylamine. If this breaks off, it's going to produce ethylamine. And that part will produce a carboxylic. I mean, this part over here will produce a carboxylic acid. So what does he mean with this part? Now he's saying there's another isomer which does exactly the same thing, that it produces ethylamine. Now we've got a problem over here, that is, if I break this, this is the only amide that is going to produce ethylamine. He's saying there's another amide with the same formula, and that also produces ethylamine. So how can you have another amide with the same formula? I mean, the salt is going to be this one. This side will turn into a carboxylic acid, and that will produce a salt. So what could be the other isomer that produces the same kind of stuff? I think it's going to be Mark scheme checker. Let's say this is, I think he gave this exactly the same. He's saying it's the same thing. It's this one. This side turns into a carboxylic acid. I mean, the answer is exactly the same, but the problem is this over here is exactly the same molecule that we drew over here. It's exactly the same amide that we drew over here. I mean, the question may problem aa gaya. There's a fault in the question. And there's one mistake in our acha, ye choti si mistake thi. This is fine, there's nothing wrong with this. There's one very tiny mistake which we did not spot when we drew this. Usse jab P and Q kaha tha na, it's split into P and Q. So there was C6H7N. So he said that when the amide broke, it produced C6H7N, and it also produced Q, which was C3H5O2. O2 minus 1, Na plus 1. So if this molecule breaks into two, this side is the benzene, so the N must have been on the left side, not on the right side. So ye jo amide ka jo link hai na, we actually drew it the other way around. So that's why this one is incorrect. Is this part clear?
Yes, sir.
Because we had to. So it's basically I mean, people when this question came, most of them were not able to actually finish this question. Even after doing all of this, we're still finding a mistake over here. There was just too much data given and too many things to look after. But now we're actually done with this. Amide, add here, we're missing. You put a question difficult. This paper, this entire paper was kind of very, very difficult. So let's do another question. Let's do this one, question number 6. We're done with question number. We're done with question number 5. You want to have question 5. So now question number 6. There's a rate of reaction can be studied by measuring the amount of hydroxide ions that remain in the solution at a given time. The reaction can be effectively be stopped if the solution is diluted with an ice-cold solvent. Describe a suitable method for studying the rate of the reaction at a temperature of 40 centigrade given the following. So you are being asked to figure out how to follow the rate of the reaction. So he's not asking you to actually measure the order of the reaction, just follow the rate of the. What is the best way to follow the rate of reaction? Like, what graph should I make if I want to follow the rate of the reaction? What graph? It's just follow. I mean, basically at the end, what I'm going to do is I've I'm going to follow the reaction with respect to time, and I'm going to plot any change with respect to time. So what is the change that I can measure with respect to time in this experiment? There is no mass change because everything I think is aqueous. Mass change tab hota hai when some gas appears and it leaves the container, or so I don't think mass change can be followed. Concentration, right? But how would I measure the concentration of let's say OH ions? I mean, the OH ions will decrease, right? So उससे मिलके लिखा हुआ भी, you have to measure the amount of OH ions. So how would you measure the amount of OH ions? Okay, so pH will give you an idea of how the OH ions are changing. He did give us another method as well, that you stop the reaction by adding an ice cold solvent. And Zua send किया था मैंने, मुझे फिर वो मैसेज करता है ग्रुप में. I'll share the PDF. Transition नहीं, inorganic कौन सा transition metals, ठीक है, that's the only inorganic we have. अगर yes का चाहिए वो भी भेज दूंगा. Achha, so anyways, OH ions. The other method was that you add an ice cold solvent and then you do titration with maybe HCl. So, achha, so उसने glass पे सब कुछ दिया हुआ है. He did not actually give you the pH meter. So what you're going to do is every time, let's say you're going to stop at different time intervals, take a sample and then titrate it with HCl. Because I don't think he gave you the pH meter, although that's going to be the easiest way of measuring the rate of the reaction, because with pH you can figure out the OH ion concentration. But if look at the apparatus, nothing is given about calculating pH. Any device that calculates pH. So I guess the only option is after, let's say, at regular time intervals, you're going to add the ice cold solvent, and then what you're going to do is you're going to titrate the solution with HCl, and you're going to find the OH ion concentration because they gave you HCl. So we'll just read through the points that are given. Record the pH. pH is still an option, although it's not. The apparatus does not contain pH, but that's still an option. So first thing is you have to ensure that everything was at 40 centigrade before mixing, because he said everything should happen at 40. हाँ, लेकिन वो इस पे बताना नहीं है कि you just have to tell them that by using pH you can measure the OH ion concentration. That's it. Mix known volumes of A and B and start the clock, regular time intervals, add ice cold solvent, titrate against HCl, repeat the time at known time intervals. You can do it after every regular. अच्छा नहीं, मैं वो ठीक है, उसने allow कर दिया. I just thought कि you just had to use the apparatus that was given to you. So over here he's using pH meter. So at regular time intervals you record the pH and repeat the pH at regular time intervals, and from pH you can measure the OH ion concentration, so you can plot the OH ion concentration. Okay, so it's simple 4 marks. You don't have to go into a lot of details. Is this clear? Ab aage calculations. Figure out the order with respect to, and remember, whenever you get this question, you have to keep all the other variables constant, specifically temperature. The total volume of the solution has to be kept constant. Okay, so there are some variables that have to be kept constant because they're going to affect the rate of the reaction. I said this one, you have to find the order of the reaction. Like if I want to find the order with respect to the chloroalkane, which two experiments should I compare?
First and third.
Okay, first or third में ना, The OH is not doing anything, so that's not a factor. This increases how much? 3 times. By what amount does the rate increase? That's also 3 times. So what is the order of the reaction?
First order.
Yeah, that's order 1. Directly proportional. Order 1 is that it's directly proportional. So that's first order, order 1. So, and this is exactly what you're going to write. You're going to say you're going to compare experiments 1 and 3. The concentration of the haloalkane increases by 3 and the rate also increases by 3. So that means it's order 1 with respect to the halogenoalkane. Now, अगले पे आ जाओ. How would you figure out the OHN order? Which experiments would you compare?
Either 1 or 2 or 2 or 3.
The problem is that you have to keep the other concentration constant. Okay? That should not affect it. So how do you ensure that the other concentration is kept constant? Yeah, you can find it directly as well, by the way. Like if you compare 1 and 2, how would you know the order with respect to OH ion? By just looking at it, you know that this is order 1. So if this doubles, the rate also doubles. So what is the contribution of OHN? Nothing, right? You're doubling OH and nothing is happening. So it is 0 order. Even the next one, like if it increases, like if you go to 0.2, I mean, you can just look at 1 and 2. That will tell you because you already know the order with respect to this one. So this doubles, this doubles. So what is OHN doing? It's doing nothing. Okay, so that means it's order 0. Is that clear?
Sir, OH भी तो double हो रहा है.
लेकिन उससे क्या हो रहा है? रेट पे क्या हो रहा है? अभी हमने फिगर आउट किया ना, इसका तो हमें पता लग गया ना कि ये डबल होता है तो रेट डबल होता है. तो इसका मतलब ये जो डबल हुआ है ना, इसकी वजह से डबल हुआ है ना. ये क्लियर है? तो ये जो डबल हुआ है वो किसकी वजह से हुआ है? इसकी वजह से, क्योंकि वी डिड फाइंड आउट कि इट्स ऑर्डर 1, राइट? तो OH से डबल हो गया, क्या किया? कुछ भी नहीं किया. अच्छा, दूसरा इसका मैथमेटिकल तरीका. द मैथमेटिकल वे इज your rate relationship is, I'm just going to call this is my reactant A, this is my reactant B. So my rate equation, the mathematical method is rate depends on what is my rate equation? It's rate depends on the concentration of A. That is order 1. I know this is order 1, and it depends on the other reactant, which is, I don't know what that is. Okay. So I'm going to plug in the first experiment values. This is 0.5. K, I don't know what that is. Concentration is 0.05 for A, the first reactant, and that's power 1. For B, it's 0.1, and that is X, right? Then I'm going to plug in the second experiment data into this. So it's 1, and 1 equals what? K times 0.1, power is 1. And B की concentration here, that's 0.2, and that's power is X, right? So I got this. Now what I'm going to do is I'm going to plug in, I'm going to solve these equations simultaneously because I want to know what X is. नहीं, हमने OH को order 1 नहीं कहा था, हमने किसको order 1 कहा था? This was order 1. I said the halogenoalkane is order 1. This is order 0. So A जो है ना, that is order 1. Now I'm solving it mathematically. I don't know what OH is. So that is X. But is that clear?
Yes.
मतलब अगर start से करें ना, start से हमने किया था कि हमने we compared experiments 1 and 3, and we figured out that if this increases 3 times in 0.05 to 0.15, तो वहां पे भी 3 times increase हो रहा है. So that means with respect to this is order 1. ठीक है, we did find that out. नहीं, not for OH. OH तो 1 और 3 में ना, OH तो कुछ कर ही नहीं रहा था. मतलब अगर वो 1 और 3 को कंपेयर करोगे ना, तो 1 और 3 में it was all this. OH was not doing anything in 1 and 3. अच्छा, anyways, अब हम आगे. So I'm just trying to figure out. वो तो मैंने देख के कह दिया था कि order is 0 with respect to OH, because I know कि this is confirmed that this is order 1. So ये double होगा तो ये भी double होगा, right? तो इसके double होने से क्या फर्क पड़ा? कुछ भी नहीं पड़ा. So that means it's nothing, it's order 0. So now I'm trying to prove that it's order 0 mathematically. So what I did was that I wrote the rate equation. I don't know what the second reactant order is. I have no idea, so that's X. I plugged in the values. Now what I'm going to do is I'm going to solve this simultaneously. I'm going to take this K and I'm going to substitute the first K into the second equation. So that will give me what? 1 is equal to what? What's the K in the first one? That's 0.5 divided by 0.05 into 0.1 to the power X. And then it gets multiplied by, so that's my K. Then it gets multiplied by 0.1 into 0.2 to the power X. To get the first K got substituted in the second one. Now, the 0.5 goes over here. The 0.05 ends up over here. The 0.1 ends up over here. So what do we have? This side will be 1, right? Like 0.05?
Yes.
Okay, that's 1. Or this side क्या होगी? 0.2x over 0.1x. That's going to be 2x. So 2x is equal to 1. That's what I'm going to get. And the only way that is possible is if x is equal to 0. Is this clear?
Yes.
That's the mathematical way of solving this. But it was pretty clear from experiments 1 and 2. Doubling that was not doing anything. So write the rate equation for this reaction. So we did write that. You just have to put 1 over here. I mean, put the reactants. Sorry, this is 0. And you can figure out the units of K, and you have to figure out the rate for experiment 4 as well. So first thing, rate for experiment number 4. So we know that this is not doing anything. This is order 0. So can you tell me what's the concentration of the halogenoalkane is increasing 4 times, right? So your rate should be increasing 4 times as well. So यहाँ पे क्या होगा? 2 होगा. Is this clear?
के यूनिट्स क्या होंगे रेट के?
अब वो निकाल लेते हैं कि क्या था, लिख लेते हैं इक्वेशन. Rate is proportional is equal to the chloroalkane concentration, right? Power 1. OH तो है ही नहीं. OH is 0, right? So that's out of the equation. So what's the unit for K? K is going to be, rate is mole per dm cube per second. Or concentration is mole per dm cube. So it's just S minus 1. ठीक है. और वो fourth experiment, चौथा experiment का rate भी निकाल लिया. ठीक है. So we're done with that. Then use your answers to help you to draw the mechanism for the reaction of 1 chloropropane, 1 phenyl ethane with hydroxide, including the following. So, Acha, is this an SN1 or an SN2 mechanism? ये बेस आ गया. पहले तो वो देख लें. C6H5 CHCl CH3. 1 second. So C6H5, that's benzene. CHCl, और फिर क्या था? CH3. So now this is a halogenoalkane. Now in AS you had AS के notes का है. अच्छा, in AS you had, एक second. अच्छा, in AS there were two mechanisms. आइए. One was for, it is SN1. SN1 का मतलब ये होता है कि only it depends on one of the reactants, right? 2 का मतलब होता है depends on both reactants. In our case, it depended on just one reactant. So we have to draw this one. So remember, tertiary was SN1, primary was SN2. In our case, we have a secondary. Secondary का नहीं पता होता. Secondary, you don't know what is SN. Is it going to be SN1 or is it going to be SN2? But because the rate equation had only one reactant, so ये one वहीं से आया था. So that means it's going to, the Cl is going to break off first, and then the OH is going to come in. So that is going to be your reaction. So first step में Cl will break off, and then carbocation बनेगा CH3. The Cl is gone, and then the OHN comes in. So it's an SN1. So one जो indicate करता था ना 1, that was this one, that the rate depended on just one reactant, not on the other one. SN2 का मतलब होता था the rate depended on both reactants. Is this part clear? Nucleophilic substitution है, ठीक है? बाकी के reaction was carried out using a single optical isomer of 1-chloro. Use your mechanism to predict whether the product, actually this one, will this is interesting, will this be, how many different, he said they only used one single optical isomer. This molecule is chiral. So they used only one optical isomer. So will the product have 2 optical isomers or will it have 1 optical isomer? क्या होगा?
Two.
और 2 क्यों होंगे? मतलब एक ही optical isomer से start कर रहे हैं, you just have one optical isomer. So why will your product have 2 optical isomers? इसकी shape बताओ. What is the shape of this? Carbon is making 3 bonds, right? So what is the shape when it's making 3 bonds? Three bonds की क्या shape होती है? That's tetrahedral, right? Tetrahedral कह रहा हूँ, fan shape, trigonal planar, right? So there's going to be a CH3, there's going to be an H, and there's going to be, and this carbon in the middle will be, so it's like a fan. I mean, this is the actual shape, 120 degrees, and the carbon, I mean, this one, I drew this one. You clear? So I drew this one. Now what will happen is, there's going to be an OHN coming in. So imagine there's a fan. Now the OH minus one could attack the carbon from the top. तो वो fan में ना ऊपर से top से, it can come in and it can join. So your molecule will become, I mean, the fan bonds will actually bend downwards. The CH3 will bend downwards, the H will bend downwards, and the C6H5 will. And the OH will bond at the top. Okay, so that's one option. That your carbocation, which is trigonal planar, the OH ion comes from the top and bonds. So you get this one. And you're going to get the other one, the mirrored version. If the OH minus one comes and bonds from the bottom. So you're going to get an upside down mirrored version of the same molecule. So that means you're going to get two optical isomers. The OH can join from 2 places. बिल्कुल सही है. ठीक है, ये चीज याद रखनी है कि you'll be asked one mark, probably 1 mark, 1 or 2 mark questions on this. The carbon, the OH minus one nucleophile can join from 2 places. ठीक है, from the top and from the bottom as well. So you'll get the other one as well, which is going to be exactly the opposite. It's going to be an upside down mirror. नीचे से अगर वो आएगा ना, so all the bonds will go upwards. So all the C6, H5, CH3s and your OH will bond from the, it will bond from the bottom. So both molecules, both enantiomers will be produced in this case. The question is still, it's ये देख लेते हैं, NMR भी कर लेते हैं, एक सेकेंड. अच्छा ये जल्दी से quickly कर लेते हैं. NMR, proton NMR, C6H5. So I'm going to draw C6H5 is probably, it's probably benzene. And CHOH. And then you have CH3. And then you have lots of H's. As a first thing, how many proton environments do you have? This CH3 protons will be resonating together, right? This H will be resonating in a different environment. This HOH will resonate at a different environment. And then you will have the benzene H's. You CH3, that's a doublet. Why? Because the neighboring carbon atom has one H. If the neighboring carbon atom has one H, it's a doublet. This is going to be a quadruplet. This one is going to be a quadruplet. Why? Because the neighboring carbon atom, I mean, the other neighbors don't have any H. This carbon atom has three H's. This one, OH, is always a singlet. और ये आपका benzene का आ गया. All of these will resonate. Benzene को उसने खुद ही दे दिया, ठीक है? The benzene C6H5, ठीक है? He gave you those. So I guess you just fill it up. You can figure out the chemical shift value by just looking at the data booklet. Do I have the data booklet?
Sir, वो H quadruplet और OH singlet क्यों?
नहीं, एक तो ये याद रखना, OH और NH2 हमेशा सिंगलेट होते हैं. OH जो होता है ना, उसमें इंटरफेरेंस नहीं होती, क्योंकि जो H है ना, ये अलग रेजोनेट कर रहा होता है, तो वो कट ऑफ हुआ होता है बाकी मॉलिक्यूल से, ठीक है? So there's no interference from other hydrogen protons. So the OH and NH2 are always singlets. Is that clear?
Yes.
Benzene multiplet इसलिए क्योंकि benzenes are very similar, but not all of them are kind of exact. अच्छा, benzene का confusion होती है थोड़ी सी कि benzene, all of them are not exactly the same environment. They're kind of very similar, but they're not exactly identical, which is why it's always a multiplier. उसमें हमेशा थोड़ी बहुत variation आ रही होती है. Like this hydrogen is slightly different from this hydrogen, but very slightly. Is that clear? तो benzene जो होता है ना, it's always a multiplier. और benzene क्योंकि कोर्स में भी नहीं, उसने इसलिए खुद ही दे दिया, ठीक है? That's like, I mean, the knowledge that benzene is a multiplier, that's not really in your course. But you can just note it down that it's kind of going to be not a single peak. It's going to be a bunch of peaks all grouped together. अच्छा, फिर doublet ये है कि उसका n+1 rule होता है. If the neighboring carbon has one H, so that's a doublet. This neighboring carbon atom has, इसके carbon के कितने H हैं? 3 H's. इस वाले carbon पे कोई H नहीं है. नीचे वाला OH वो हमेशा वो किसी को तंग नहीं करता, ठीक है? तो it just has CH3, so that's a quadruplet. एक ज्यादा quadruple 4, ठीक है? बाकी डेटा बुकलेट से देख लो कि किसकी पीक कहां पे आती है, right? Is that clear? बल्कि देख लेते हैं, जल्दी से इसको खत्म करते हैं. ताकि क्वेश्चन कंप्लीट हो जाए. Just 1 second. अच्छा ये किधर गई हमारी NMR, कार्बन NMR, this one. अच्छा क्या था, CH3 CHOH. So CH3, I think we have the 0.9 to 1.7 CH3, which is next to CH3 next to cetyl bond O भी नहीं था, CH3 next to O भी नहीं है. So I guess the only one that's close enough is CH3. So that's 0.9 to 1.7. So that's the only one. So 0.9 to 1.7. ये वाला, ये वो CH3 वाला है. और वो नंबर ऑफ H 3 हो गए, ठीक है, वो इसके बारे में लिख दो सारा, ठीक है. 2.7 and 4. So we're left with, ये तो बेंजीन वाला भी हो गया, ठीक है. So these two are done. So we've got CH and we've got OH. OH, let's try and figure out OH first. So where exactly is OH? OH, and it's a normal alcohol, that's 0.52. The OH could be anywhere, by the way. So CH next to O kya hota hai? That's this one, 3.22, 4. So I think ये जो CH next to O है ना, that's the 4 one. It's this one. OH कहीं भी हो सकता था. OH की जो रेंज थी ना, that was 0.5 to 6. ये जो था ना, the CH next to O, that was 3.2 to 4. So this one is definitely this one. और इसके अंदर सिर्फ एक पीक गायब होती है when you add D2O. Which is that peak? D2O में it's always the alcohol peak that disappears. NH2 या फिर alcohol, that, or OH, any OH, carboxylic acid OH. The H ionizes and it is lost and it gets replaced by D. तो वो disappear होती है. चलो ठीक है, ये clear है question?
सर ऑर्गेनिक वाला क्वेश्चन को मतलब जल्दी में करने का क्या तरीका है?
नहीं, ये वाला तो क्वेश्चन ही वो था,
वो जो शुरू में किया था हमने.
ये वाला क्वेश्चन तो कभी भी जल्दी होना ही था. मैंने वो कुछ भी कर लो ना, इस क्वेश्चन में कोई वो नहीं था. ये क्वेश्चन जब पेपर आया था ना, किसी से नहीं हुआ था. तो मैंने उसका जल्दी करने का तो कोई तरीका नहीं है, क्योंकि वो हो ही नहीं सकता जल्दी. उसका बस यही तरीका है कि आप बाकी पेपर जल्दी कर लो, और फिर इस तरह का कोई क्वेश्चन आ गया ना, कोई इस तरह का क्वेश्चन अगर आया भी ना पेपर में, पहले आसान वाले पहले कर लो, ठीक है, फिर उसके बाद टाइम लगाओ उसके ऊपर. तो वो एक, रिमेंबर आपके पेपर में एक क्वेश्चन लाजमी ऐसा होगा which is going to be very time consuming, so it would be very I think गलत होगा अगर आप टाइम उस पर जाया करो. मतलब आप बाकियों पर पहले कंप्लीट कर लो जो आसान है, ठीक है. जैसा ये आसान था, मतलब ये अगर आपको आता है तो आप बस जल्दी से खत्म कर लोगे, ठीक है. मतलब इसमें इतना सोचने की बात नहीं है, लेकिन वो वाला जो है ना, उसके अंदर तो आपको बहुत, उसके लिए मसला ये कि आप जल्दी में वो क्वेश्चन कर भी नहीं सकते, क्योंकि जल्दी में तो आपको समझ भी नहीं आएगा क्वेश्चन, ठीक है. उसके लिए आपको टाइम चाहिए और उसके लिए आपको बड़े सुकून से काम करना पड़ता है. तो आई गेस वो वाला क्वेश्चन सिर्फ तभी होगा जो आई हैव नो आइडिया कि मॉक्स में क्या है, ठीक है. बहुत पहले मैंने बनाए थे. चलो ठीक है, ओके. रानिया मैं ग्रुप में शेयर कर दूंगा, ठीक है.
Do you have any videos for paper 5?
ठीक है, we can do paper 5 tomorrow.
Okay, but do you have any like videos I can start with?
I'll check. I'll send them.
Okay, thank you.
Let me check. Okay. Take care.